Morning. So let me proceed to share my screen in a minute so we can get started. Okay, is my screen visible? Okay. So hello everyone. Again, thank you so much for joining. I have been looking forward to this session, and I'm so excited, to facilitate this session alongside my colleague, Raphael. My name is Ruth Ikega, and I'm based in Lagos, Nigeria, and I'm the open source manager at OSPO now, like Joel said. I have been in open source for over 5 years now, and I also have a background in science, particularly microbiology. So I'll let Raphael do a brief introduction before we get started.
Thank you, Ruth, and hi everyone. My name is Raphael Sonnebend. I'm one of the co-founders of OSPO now. My background is in open source and artificial intelligence, and I would like to think about how we can make open source and software and models and data as accessible as possible. And I hope that's one of the things that we can learn today. I've just seen a note to speak up a bit more, so I will make sure that I will talk loudly, and Ruth, I'll ask you to do the same. Thank you very much. Over to you, Ruth.
Yeah, sure. Thank you so much, Raphael. And yeah, let's get started. But before that, I usually like an interactive session. So let's do a little icebreaker for maybe 2 minutes. And I see it's the full room, so and there's a lot of diversity here. I want to meet you as well. So could you please drop in the chat what country you're joining from, what's your profession, and tell me one thing you also want to learn today from this session. So I'll be watching the chat as we drop our responses. Hi, Shakira from Uganda. Oh, I see someone from Nigeria as well. Hi, Andrew. Clifford from China. Interesting. Nice to meet you. Also, let me know what you do and where you're joining from, and one thing you want to learn as well. Okay. Okay, someone wants to learn about automation of code. Interesting. How to use GitHub. Yes. Hi, Bisola from Nigeria. Ruth from Kenya. That's my name too. My namesake. Okay. Nice to meet you, Ruth from Kenya. And my co-facilitator wants to learn about open license. Okay. Nice to meet you, John from Kenya as well. Awesome. So thank you so much. Keep dropping in the introductions. I'm sure my colleague also would love to see where you're joining from as well. Keep dropping those introductions and letting us know what you want to learn so we can also, emphasize on those things. So the agenda today, we have a packed agenda. It's going to be a long session, and I'm so excited that you're all here, and I hope you stay till the end as well. We're going to go through open science. I'm going to introduce the concept of open science to you. We're also going to talk about research transparency, reproducibility, and credibility revolution as well, and the crisis and how factors that can combat that. And we'll now dive into open source software. We'll talk about what open source software is. I'll give you a short history of open source software and how open source software came about. And we'll also talk about the importance and the synergy of how open source software is connected to open science and how it kind of works together. We'll also talk about open source management workflow. I'm aware that you're all building teams and building projects. So we'll talk about how you can manage your open source projects using GitHub. So this is just to put out there, if you're not joining with your computer, please do join with your computer. And also we'll be having a very interactive hands-on session as well, where you all be creating your own open source projects, your own sample open source projects. So it's going to be a packed session and I'm excited to dive into it. And with this session, you, alongside all the beautiful things you have told me you want to learn today, of course, would you understand why open source and open science is important, and how you can go about making your research open, and what are those things that funders expect to see when you're applying for grants, even like the mental health data prize, and also how you can keep progressing your career through open source and open science, because the journey doesn't end here in this session. I'll also be sharing resources with you that you can use to continue learning about open science and open source. So let's get into it. So let's go into first the introducing open science as a concept, and what is open science. Open science is the process of making scientific research accessible to any level in the society, amateur or professional scientists. So open science kind of combines all the various movements and practices aiming to make scientific knowledge openly available. So take note of these keywords because throughout the session is something I'll be referencing. So it makes scientific knowledge openly accessible, available, and reusable for everyone. It also helps to increase collaboration among and sharing of information among scientists, right? It also opens up the knowledge creation, curation of scientific knowledge, evaluation, and also, enhances communication between societal actors and scientists just beyond the traditional software community. And this screenshot I have here is not so visible, but I hope you can see it to some extent. I'm going to be breaking this all down. Now, this screenshot I have here is the pillars of open science, according to the UNESCO, the 2001 UNESCO Open Science Recommendation. And UNESCO has been a key player in the open science movement, and they've developed a lot of recommendations over several years. And these pillars were developed during the 41st session, during one of the sessions, the UNESCO General Conference. And they broke down these different pillars, and let's look at these pillars individually. And these are the kind of the core components of open science. So as you create your projects, as you create the project that you're working on for the mental health data prize, you should take note of these different pillars. Now, the first one here is the open scientific knowledge. Now, open scientific knowledge refers to open science, open access to scientific publications, open research data, open educational resources, open source software, which we'll talk about in depth, and even open hardware. Now, it's all these components are open access, and it's available in the public domain or under a license, and it allows anyone to access, to reuse, to repurpose, even adapt these different resources, right? And it's open to everyone, regardless of their age, their race, their gender. It's open to the public, under the public domain, and is made free of charge. So scientific publications could include, the scientific publications here could include peer-reviewed journals, it could be books, research reports, even conference papers as well, all stored in online repositories, right? And for the data aspect of it, the open data, it refers to either raw or processed data. It could be metadata, it could be even textual records, it could be image or sound, it could be protocols, analyzed data as well, being made open as well, and accessible to the public, right? And then for the educational resources, we're talking of like teaching and learning resources. I do see that we have like, there are a lot of platforms, there are a lot of platforms that have like open educational resources, which Mental Health Data Prize is, also has like open courses available that you can take. So these are like examples of open educational resources, and even open source software and open hardware, maybe design specifications of physical objects that are made publicly available. And I think one of the things that, especially with say research data, it's sometimes people have this they think that, okay, if I make research data public, it's open to bad actors, right? Maybe it's vulnerable to the public, and when that is made public, it's open to bad actors. But one of the recommendations from open science, the UNESCO pillars, is that access should be made open as possible. But in cases where it's only justifiable that you can anonymize data, in cases where you're trying to protect human rights, if there's like confidentiality issues, so you can, maybe use practices like anonymizing the data to reduce any vulnerabilities, right? So this is one of the pillars. And now let's look at the next pillar, which is the open science infrastructures. Now, this could be virtual or physical infrastructure. Virtual infrastructure involves like resources, publications like we talked about earlier, journals as well. Knowledge-based resources are classifiable under like virtual infrastructure. And then when you look at the physical infrastructure, it includes scientific equipment, scientific laboratories, research facilities, science museums. They should all be made openly accessible to support the open science movement. And also the open engagements, the next pillar would look at is open engagements of societal actors. Now, this involves extended collaboration between scientists. So it's not just working in your own silo, scientists gathering at one point, doing all their work, but this pillar encourages engagement with different societal actors beyond the scientific community, and it opens up, practices and tools for the research cycle and helps other people get involved. It could also open up to new forms of collaboration like crowdfunding, crowdsourcing as well, even scientific volunteering. Among societal actors, people can get involved in the work, and it also opens up like a dialogue between stakeholders during the research process. So the last pillar, according to the recommendations from UNESCO, is open dialogue with other knowledge systems. And basically what this refers to is dialogue between different knowledge holders, inclusion, including marginalized scholars, people that their knowledge is not included globally, right? Using this approach to recognize the different values that this set of people, marginalized scholars, indigenous people, and even local communities bring. So these are the different pillars of open science, and these are the different components that you think about as you create your open science project. And now let's look at some of the actions. And also, if you have any questions, feel free to also drop them. There'll be a Q&A session towards the end, but you can also drop your questions if you're confused about anything, and I'll try as much as I can to look at the chat and answer some questions as well. So now let's look at, there are some of the actions and initiatives that support the growth of open science. Example, Open Science Project. And I think that's one of the goals of the Mental Health Data Prize. There's also like advocacy, which bodies like UNESCO is doing a lot of work in that regard to spread the movement of open science, and even governmental bodies as well, and organizations like this. Another thing is journal support, encouraging the open access of publications, journals, and creating platforms that would promote sharing of knowledge, scientific sharing of knowledge. And then the last part, there are so many of them, but the last part is open source software. The way open source software is built kind of encourages the growth of open science. And like I said, there will be a section where we get to talk about that more in depth. So now we've talked about open science. We've discussed those different pillars. Now let's talk about what's like research transparency. How does open science connect with this concept? How does open science connect with the computational reproducibility? Why is it important? And even credibility revolution. So research transparency is basically openly sharing all aspects of the research process, including the data, the methods, the materials, the analysis, the scripts, that so that other researchers can evaluate and understand the work that you are doing. So as you go about building up research, you should build it up in an openly accessible way to include every method, not removing one part of the research process, because as we go down, you understand why that is really like involving openly sharing every aspect of the research process is important, right? Research. Now, the next concept I want to introduce is computational reproducibility, and basically this is the ability for another scientist. You can see this image that I put here. This is a different scientist, mixing up their methods and everything. And this is another scientist asking that question: how do I get the same result? How do I, reproduce this in another setting under the same conditions, right? So computational reproducibility, the ability for a scientist to be able to repeat the results of a research using the same computational methods, maybe the data, the code that were originally used in the first process. So as you go about making your research open, you should also build upon it. It helps ensure like scientific findings are reliable. It helps ensure credibility in the research process and even in open science. Now, there are some of the issues. There's something we call the reproducibility crisis that prevents scientists from having like mistrust in data or in the research or even in open science in general. And let's look at some of the factors that can, that contribute to this crisis. One of it is publication biases. And this is basically like the tendency for journals to kind of publish only mostly positive or significant results over null findings or even negative reports, which kind of like brings misleading picture of evidence of like, scientific literature when there's like a whole lot of positive, and it's fine for there to be like a lot of positive research reports out there, but the part of the bias comes with when they hide out like the negative ones or the null findings and publish more of the positive results, right? Another thing that can contribute to this crisis is also p-hacking, and this is the practice of analyzing data in multiple ways, compromising the data for the results to be statistically significant, right? Regardless of the validity of that research process. So this is also another factor that contributes to the crisis of reproducibility, and it prevents research not to be reproducible under the same conditions. Another thing is more of the culture of the lack of data sharing among scientists. And this is, failure to share the raw data and detailed methodologies. How did I come about this process? What are the different factors? What are different things that I considered? Like, what were the conditions, right, that I came about this particular method? So there's also the lack in data sharing among scientists that kind of contributes to reproducibility crisis. There's also insufficient reporting, and this is with documentation. Documentation can be difficult to write sometimes, and it contributes to this problem in the sense that when there's inadequate documentation of the methodologies that you use, of the experimental procedures, or even of the analysis method, it limits understanding in a way that another scientist will not be able to replicate or reproduce a research that you carried out, or research report that was carried out. And another is the pressure to publish. And this is something that, in academia, as researchers, we always want to publish a lot of publications, a lot of papers, and sometimes some people would compromise on quality at that point because of the high volume of publications that people want to push out. Another thing is inadequate peer review. And peer review is a very important process in research. But when there's inadequacy, there's no thoughtfulness, or there's no when the peer review fails to detect issues with maybe the study design or the methodology, or maybe the data interpretation method, it becomes flawed, and it contributes to reproducibility crisis. And then the use of data, proprietary data or methods, using proprietary tools, tools that are not openly accessible, and that's what this means, like tools that are not openly accessible to the public. Using these kind of tools can make it hard for people to replicate, especially with the different challenges that some marginalized or local communities may face. That can also contribute to the crisis. And lastly, the complexity of research. There are a lot of advanced and specialized research methodologies that makes replication really hard to achieve, especially when the detailed procedures are not fully disclosed. So these are some of the factors you should be aware of as you go about making your research transparent and even reproducible. So take note of these different things while you go about your research process. Now, the last concept is credibility revolution, and this refers to a shift by the scientific community to address and resolve issues that or the crisis that comes about with trying to reproduce research reports. One of them is the emphasis on open science practices, advocating for the open sharing of data, and communities have been taking this seriously in aspect that openly sharing data, you can enable verification, and it would enhance credibility to know that this research is reproducible. Another thing is pre-registration of research. So this is basically encouraging researchers to register their study design just before they carry it out, so that it kind of brings accountability in some sense. So if they're able to pre-register their research before they carry it out, it reduces some bias and enhances transparency in the research. Also is the encouraging scientists to carry out replication studies as well to verify the reliability of some research findings. Another thing is adopting registered reports, implementing that publication format where research questions, methods are peer reviewed before it's published out. And the last day, I'd like to talk about developing new metrics for success as well, moving away from citation count, how many people cited it, to more of metrics where we measure reproducibility or measure the contribution to how open or accessible this research is. So moving away from those quantitative metrics to more of like a qualitative metrics. Now, some of the open science practices that efforts to combat also research. It's just complementing the previous slide, data sharing amongst scientists, so making raw research data openly accessible to others and even to the community, scientific community and other societal actors, so that it allows for verification of the results and the reuse of data. Another is open access to the research findings. As far as someone has an internet access, they could, access these publications. It's not behind a paywall, right? And another, which I talked about earlier, pre-registering research, so that, it enhances accountability. Also, another thing is preprints. This is just basically sharing manuscripts before they are peer reviewed, so that other scientists can weigh into the work, and open critique can also be done on the research finding. Another thing is open methodology, providing detailed description, like every part of the research process, like I talked about, make every part open and accessible for people to understand how to replicate the work. Encouraging more open peer review. You could disclose the identity of the reviewers at some point, and encourage peer review being done in the open, so that other experts can weigh in on the work. Also, open educational resources. This is indispensable, because as we keep advancing, we need to learn more ways in doing things, learn more ways to make our research more open. So encouraging the creation of educational resources, so that we could disseminate knowledge across different communities, and encouraging replication studies. Like I said earlier, encouraging scientists to verify other findings through replication studies. So I'll pause there and see if there are any questions. I don't think I see any on the chat, and I think everything is good. So let's go to the next session, which is open source software. What is open source software? And so also take note of the terms as well here. Open source software is software that the source code is publicly available. It permits anyone to freely use, modify, examine, redistribute, and share it. And open source software thrives on collaboration, right? Where, community contributors frequently update and enhance the project through bugs fixes. Now, the keywords I want you to, there are some particular things I want us to discuss about open source software. And if these things are taken out of it, it is not open source software. So before I go into these different things I outlined here, let me use a popular example to differentiate open source software from proprietary software. Now, let's use the two popular operating systems, the Linux operating system and the Windows operating system. So maybe you could drop in the chat which of these operating systems you use, and I'll be excited to know how many people use Linux versus Windows. So maybe in the chat, you could also put down what operating system you use. I see some Windows users. And if you use Mac as well, you can say that too. Okay, somebody uses all three. That's great. I use all three. I have all three actually. So great. So let's use that example now between Windows and the Linux OS. Now the Linux operating system is open source, and now let's look at these different terms. Publicly available is free to use, examine, modify, redistribute, and share it. Now, the Linux operating system is open source, and if you even want to see maybe the first line of code or the first patch that was sent by like on the Linux kernel, you can Google it, and there you'd see it, like it's open and accessible to everyone. And not just that it's open and accessible, you can examine it. You can look at how it was made. You can look at the first history down to the latest one. You can also modify it. Now, for the people that say they use Linux, which distro do you use? Like, so for Linux users, you know that there are a lot of distributions of the Linux OS. There's Ubuntu, there's Debian, there's Fedora, there's Kali Linux. There are a lot of distributions, and those are modifications of Linux, right? And the ability to also redistribute and share those changes, those modifications, that's the core principles around open source software. Now, in comparison with Windows, that is closed source or proprietary, you cannot see how Windows was created. Windows is managed by Microsoft, right? You cannot see, even the software itself comes with a license that you sometimes have to buy. You know, it's closed source. You cannot see how the code was developed. You can only, I think, you changing the theme, but you cannot redistribute it because it's closed source. So those are like that's one of the common examples that I like to give when I'm, talking about open source software. So now let's go into, I see someone says the audio is not working properly. So I need maybe to confirm that I
no,
am.
it's okay. It's okay from our end.
Yeah. Sorry about that. Just maybe rejoin and I think that would solve it. Thank you for confirming that you can all hear me. So let's look at these different core principles, and this is important to you because you are all going to be creating open source projects, right? We have a hands-on session later today, later this session as well, so that we all work together. But looking at accessibility, now, this principle ensures that software is freely accessed and used and downloaded by anyone. There are no limitations, right? It's not just about the availability of the software, but it also provides access to the source code. It enables, you can see how it was, and I think that's one of the reasons I love, because of how you can learn. There are a lot of times, with my time with contributing to open source and using open source software, because like I said, I have a background in science, microbiology, and I just after graduating, or like after a few months, I just transitioned into tech, and open source was the forefront of where I started. And it helped me over time learn, because of the ability to see and understand and look through the code. I was able to learn better over time. And then modification, you're not just seeing, right? You're not just able to download, you're also able to modify the software. You can modify the source code. You can tailor it to your specific need, to how you want it to look like, to how you want it to feel, right? And this flexibility kind of encourages innovation in open source and improvements, as users can enhance the functionality of the software. Now, another one is redistribution. Now, after modifying, you can also, like, for example, if I have a yellow software, let me use colors. I love yellow as a color. So if I have a yellow software and I add a bit of color to it to make it red and yellow, right? I can redistribute that version of the software to other people, right? After modifying it, users can redistribute the software to others. And this principle supports sharing knowledge. Like, going back to the open science principle, it also supports sharing knowledge and helps build open source in a community-driven model. And the last part I want to talk about, which is also really important, is licensing. And licensing is a very important topic. So whenever you create something, right, there's a copyright. If you do not make it available under a license, there'll be some issue if I just go and use that thing without your knowledge or something. So licensing is an important issue in open source, and it's one of the cornerstones. And like, it defines how, now remember I talked about these different keywords here. It defines how the software can be used, modified, shared, and redistributed. And it kind of maintains the ethos of freedom and collaboration in open source. And licensing, they generally fall into different categories, and just basically helps you, like, the whatever you create, make sure like it's accessible by different people. Now, the two categories it falls under is permissive licenses, and some call it copyleft licenses or restrictive licenses. Now, permissive licenses, example of permissive licenses like a MIT license, the Apache license as well. It offers like broad freedom, right? To use the software, and it even encourages widespread adoption in the sense that you can even use that software in proprietary products. You can take maybe a software that was based on a permissive license like MIT, and you can use it in creating a proprietary closed source project. So that's how permissive those licenses are. And then restrictive licenses like the GPL license and the GNU license, they kind of like limit the mandate that whatever you create, it has to adhere to the same license it came from. If this software has a GPL license, that's a restrictive or a copyleft license. If you're creating a derivative of it or another version of it, you cannot change it. Like, it has to be under the same terms. So this is important as creators of open source software. Sometimes for users, it might not be important, but like for you as a creator, it's important because when you're using other people's open source software, you need to be careful around how you're using that project. Know what licenses they have so you don't fall into vulnerabilities. I think, I see a question from Stanley. How can I publish in open source science? Does it cost money? I think maybe, do you want to rephrase this question? Does it cost money to, do you mean, does it cost money to publish in like a journal? I'll just let you rephrase real quick. Okay, maybe I'll just speak.
Yes, that's what I mean. Does it cost money to publish in an open science?
Okay, so these different platforms are being maintained as well. So I think one of the funding in open science helps with is kind of like reducing that cost to publish software in these journals as well. So it depends. I think it also depends. Let me know if I did answer your question. I think I see another question in the chat, which Raphael is taking. How is Windows an open science software? Windows is not open source, like Raphael said, but Linux is, right? So those are like Windows is maintained by Microsoft and Linux is open source software. So if you still have more questions, you can also drop them in the chat. So now let's look into the history of open source software. How did open source software movement start? What are the key timelines? So even before this point, in the era of like the mainframe computers, in the era of I think I see which are, okay, let me pause here. I think I see another question. Which are open source software? So example, Linux, there's, about Android OS. There are a lot of examples that I can call. Apache, there's Android, there's Fedora. There are a lot of open source software. I think I have the recommendation slide. I have like resources where you can check out open source initiative and look more into open source software. Now, looking at the history, let's go back to the history, like I said. So let me backtrace to the time before here, before 1983. The computers then were more of mainframes before, back in the days, at least in the era of mainframe computers and big computers, right? And the hardware would come with the software. So software was not really kind of expensive at that point. But when I think PCs, personal computers came into place, computer software started becoming expensive. And then you would see companies building like enterprise, closed source software back in those days. And there's a particular researcher named Richard Stallman. He was an MIT, was working as a researcher in the MIT lab. He created the GNU project, and the free software movement was more of user freedom with computer software, that anybody should be able to access and use computer software. So that was the era of free software around 1983, and it was more of a social movement that people should have access to software without having to pay for it, like free. It was guided under four different freedoms, that software should be free and available to the public. And then down the line was the creation of the Linux kernel, and it was created by Linus Torvald, popularly known as the creator of the Linux operating system. And he also built this the Linux kernel based off of the GNU project as well. And it was more of how do we build software in a way that people can see the source code, can redistribute it, can even do different things with it, like even creating commercial versions, right? So that's his creation of Linux kind of like opened up the open source movement, and the creation of even open source initiative in 1998, and even then the coining of the term open source was done in 1998 as well. And during this time, when the widespread of open source software, people began creating products like the Apache, even MySQL, PHP as well was around this era it was created. And open source software was becoming a topic in the software world. And at that time, because of the commercial way that software was created, there started becoming oppositions, controversies about what open source software, why is open source software useful, or open source software is a threat to intellectual property, or even like from some enterprise companies, it was like a threat. There was like fear, or uncertainty or doubt from these enterprise companies, and against open source software. And that era also migrated into acceptance of using open source software, and that was when I think Red Hat also created like their own commercial version of open source software, and then companies started adopting open source software, and open source started going mainstream. We could see even when in the 2000s there was a lot of opposition from Microsoft, and then even in 2010 or thereabout, they acquired GitHub, to promote open source software. And even till today, we see a lot of components, we see a lot of funding going into open source. We see, a lot of the tools that we use, a lot of the things that we use till date are built on top of open source software. If one component, and especially on the Linux kernel, if one component would go away, some things would begin to break. So that's how open source software started becoming mainstream, and we're still improving how software is developed and still modifying and making software even inclusive. I'll pause and check the chat as well to see if there are any questions. Okay, I think Raphael got that question. Let me see. With the rise in cyber crimes and cybersecurity attack, how safe is open source? This is a very interesting question. Like Raphael said, even when you publish out there, can someone shortchange and steal your credits? Is there a part that allows researchers to claim intellectual property rights? This is a very good question, and I even have it down my slide. You know, there comes like the risks with a lot of people. There's a lot of misconception around the risks with open source software. But looking at it from this part, that, you know, because of the community-driven model, because of the way open source software is built, there are a lot of people, there are a lot of more eyes to look at the software, to be able to catch these vulnerabilities, to be able to figure out these issues and attend to them real fast as well. So looking at it from that aspect, you see how you know, open source security has become a very important topic today. There's even organizations like Open Security Foundation, I think Open SSF, that kind of is a more key player in this industry to even allow you know, to talk about, to fund open source security, to keep having that conversation. So I don't know if I did answer your question. And yes, when you have intellectual, like, depending on the license, like, this is where the license is really important, right? And if you are, I think for people skeptical about this, they choose more of like copyleft licenses, those kind of restrictive licenses. So I don't know if that helped to answer your question, Priska. That was a very smart question though. I just wait for a confirmation. If I go to the next slide.
Not fully, but we can proceed. And you can explain to me afterwards.
Okay.
Yeah.
No problem. And if you have, you can drop in the chat as well. I'll look from time to time. So now the benefits, going more into the benefits of open source software. What are the different benefits that open source software kind of, you know, provides? One is the cost effectiveness. Software is at low or no cost, and it kind of helps with a lot of companies that are looking to start off like with expensive, like instead of going off with expensive software, you can you know, start with open source software, and it reduces cost effectiveness. Also on transparency, the way open source software is built in the way that is openly available for review, right? You know, users of the software or even the community can look at the way it was built, the inner workings. And this builds trust and allowing people to check for, you know, things like security as well, and the features on their own. Another is security, like we talked about. Like I said earlier, that's, you know, there's that misconception that open source software is riskier, but looking at it from this angle, that is, even though it's open to bad actors, there are more people, because of the collaborative nature, the open nature of OSS, more good actors would be able to inspect the code, look at vulnerabilities, and, you know, look more eyes on the code, so you can catch more issues and potentially solve them before they go mainstream. Another thing is the vibrant communities that open source software is built in. You know, because of the community of developers that support open source software, that contribute to documentation, that offer support through like forums, like mailing lists, that keep developing new features. It's kind of promotes education and even improving the software, and even going down to the last thing, which is innovation. You know, the collaborative model ensures that people are, bringing in ideas that will improve that software, that would keep taking the software, accelerate the development of the software, adding new features into the software. So these are some of the benefits that make open source a very attractive option for developers and users of software. So how does open source and open science come together? What's the importance of open source to open science? How can they work together? How does the open source principles support open science goals? One of it is transparency, and because open source mandates that the source code is available for review and is open and accessible, it kind of connects with open science goal of transparency. Researchers can inspect the code behind the scientific report or the computations and know it's verifiable by anyone. So transparency is one of those principles that support open science. Collaboration is also another principle. The open nature of open source encourages contributions. Like I said, there's a vibrant community. There's a quote I used to see about open source. I came for the code, but I stayed with the community because of the community-driven model. There's a global community of developers around the world participating in that software. So that collaborative spirit can, enable cross-partnership between different fields and even between scientists as well, which is one of, the key objectives or support of open science. Another thing is reproducibility. With the way open source, the source code, the coding, how the code was developed, is openly done. Open source will enable researchers to replicate these experiments, verify the results as well of the research report, look at the methodology, and be able to reproduce and, see it because of how open source software, the source code is openly available. It's easy to reproduce code that you are seeing. Another thing is on the reusability and adaptability, which is modifying, because of how open source lets you allows for modification of software. You could use software to meet different research needs. That flexibility as well and usability in open science, it kind of connects together. And also with accessibility, removing that economic barrier, creating for more inclusion between these different bodies as well, ensuring that regardless of wherever that researcher is, regardless of their institution, or even if they have funding or not, they could also contribute to the process and improve the software. Another thing is education and also capacity and skill building. The openness of the software provides educational resources for even scholars, students, researchers, and promote skill development as well. So what is the synergy? How does open source and open science connect? It helps build the working together helps to build innovation in research. It also helps with scientists can also share and improve the software. They can work together. Scientists and developers can work hand in hand, that collaboration to share and improve software. They could create new ideas that makes innovation and making innovation accessible to everyone, and even worldwide collaboration. So these are the different ways that, that connects open science and open source community together. I see a question from Vincent. The GitHub session hasn't happened yet. It's almost happening. So still stick around. Thank you. So some of the key tools, and this you're not limited to these tools really. There are lots more of open source tools out there that can be used in scientific studies. There are still more that will be created from your help as well. So there's a Linux operating system, like I mentioned earlier. There's Jupyter notebooks. There's the Apache hard group. It's kind of like a data processing to process vast amount of data. There's also the Git version control system that kind of tracks changes, and it's like a time travel machine. I look at it like a time travel machine and helps people collaborate effectively. There are programming languages as well that help with scientific studies. There's bioconductor, there's open science framework. I think I see a question from Jacob, so we shouldn't use Excel. You're promoting the use of open source software because of those components I talked about, open access and ability to share these resources and even build on top of it. So I encourage you to use more open source tools, but if you're also comfortable with using Excel, that's also fine. So some of these tools, there are a lot more tools that can be used. So how can we improve collaboration between open science and open source? What are the ways collaboration can be improved between these two bodies? Like, how can these two bodies kind of improve working together? So open source and open science, promoting open standards and interoperability, in the sense that data and research output is easily shared, assessed and integrated across different platforms or disciplines. And it's not limited to just one platform, right? So that's one of the ways to improve collaboration. Also by strengthening community engagement. Also by strengthening community engagement between these two, building and nurturing like a strong community around open source and open science. And we could achieve this through workshops like this, hackathons as well, forums and communities, and even conferences that bring together these research bodies and like open source developers, improving documentation and training for open science scientists and researchers, ensuring that documentation is made accessible, especially for those people that do not have background in software development as well, offering training programs to researchers as well, to help educate them on how to write documentation, how to document their research process. Also encouraging contributions to open source software. And open source software, I think one of those misconceptions out there is the fact that people think it's just about the code, right? There are a lot more contributions you can make. So scientists can also make contributions to OSS, open source software. There are a lot of ways you can help improve the software beyond code, fixing, requesting for features. And also there should be rewards. These days we look at incentives to bug fixes. That's also something to encourage contributions in open source. Another thing is integrating OSS in like the research funding and policy process. So funding institutions and agencies, kind of like encouraging the use of open source tools in research projects and offering grants, like this one that we're currently doing for developing and maintaining open source, and also policies that support sharing of research software as well. And also facilitating access to research infrastructure, the different infrastructure we talked about, the physical or virtual infrastructure, promoting access to those infrastructure as well, supporting sustainability. Sustainability is one issue, one very important topic rather that is being talked about a lot, how people are supporting open source software and fostering that continuous cycle of sharing and improving the software, and also championing open licensing, so that software is made available, like even the derivative works, that people do not just create derivatives and make it closed. It remains open for continuous improvement of open science and open source. So I think, so let's move into open source software management using GitHub. So this is the GitHub part. We're going to be using GitHub. There are other, tools as well, like GitLab, but we'll use GitHub today to talk about open source software management. As you're creating your open source projects, what workflow, as you're working together with your team, building teams, how would you maintain workflow within your teams and, manage your software better. And GitHub is GitHub helps with doing a lot of the features with GitHub help you maintain your project, and we'll be looking more into that. I'm going to be explaining these different concepts, and please do take note of them because during the hands-on session, we're going to be practicalizing these things. So do take note of these different concepts as I explain the tools for effective collaboration. Now, commits. Let's look at what commits are. So commits, look at commits like a snapshot of your project, right? Like a record of your project in time with a particular message. So the commit shows what files that were changed in the project, right? What file was changed, what line of code was added. So that's what the commit shows. And each commit is usually identified with a hash code, right? Tied to the contributor that made it. So as you're making, even as you're creating your project, as you're adding changes into these projects, these are commits. They are in form of commits, right? Now, another concept, another feature or another tool is pushing. Now, pushing refers to sending your commits from one repository to another repository. So when you make a change, when you want to send that change, that's when you refer to pushing. You're pushing your code. You sometimes hear developers say, I'm pushing code to this repository, right? So that's what that means. And then pulling code. And this is the process of kind of fetching, like dragging in changes from another repository, from like a shared repository. So say, for example, I have a repository and I have some change. You made a copy of it, which we'll talk about forking in a minute, right? You made a copy of it, right? And I add more lines of code to my project, right? So your own copy will be outdated. You need to pull that code into your own copy, and we'll see how all these things work in a second. Also, branching is a concept of creating copies of your repository, like the development line in your repository. So basically what this means is I have usually the main copy, the original one is usually referred to as the main branch, right? So I have a main branch, and say, for example, I want to experiment with some changes. I want to add new things, right, to my project, right? Using branching will help me create different development lines or different copies of the project and experiment on those changes and merge it, send it back to my main copy. And we'll also look at this. And forking is making a copy of the entire repository of another person's project to your own repository, making a copy of that. And it allows you to make changes independently to that project on your own side, right? And also when you want to propose changes to people's repositories or to people's projects, it's always encouraged that you fork the project to be able to do that. And then the concept of pull requests. Now, pull requests, after making a fork of a repository, when you're trying to send code to another repository, another person's repository, you make a pull request. Pull request is also applicable when you're doing branching, right? When even within your own repository. So for you to send that code that you have on your own copy to either the main branch or to another person's repository, you need to make a pull request. And in the concept of open source, code reviews are really important. When you send code, sometimes you might have questions like, okay, if everybody's allowed to send pull requests, how do I know which one to merge? So code reviews, that's where code reviews come in place. And maintainers are people, maybe the creator of the project, or some people that are set to manage the project, can review the code, look at, okay, what did X person add, what did Y person add, and review to make sure that we're merging correct things to the main branch, so it doesn't lead to like security vulnerabilities, for example. So that's what code reviewing refers to. And then there are a lot of a couple of community engagement tools that GitHub offers to help foster like a vibrant ecosystem where people can collaborate better. You look at things like issues. GitHub issues are ways that people, can report bugs, can request new features in the project, and also request tasks or take up tasks, right, in the project. So issues is one way to do that. Also with discussions is also another feature that kind of enables collaboration. So GitHub has this feature where you can enable discussions in a repository so that open conversation can go on in that repository. There are also GitHub wikis as well that help with documenting like things like how to start up with the project, how to use the project, the different components of the code, documenting the different features. So wikis kind of help with doing that work, and we'll see all this as well. Now, in order to also optimize the workflow and manage your project better, GitHub also offers like some issues. As you create your open source project, people are going to want to contribute to it. So how do you manage your open source project? You could do that through issue tracking. So issue tracking allows people create, like, you could have labels on issues that you want. Maybe, for example, this issue can be, you can create labels like, this issue is for code, this issue is a documentation issue, this issue is a QA issue, this issue is a discussion, something like that. So you can create different labels for your issues, and you're able to track the development of those issues, right? And how that issue, goes over time. Also, project boards. GitHub has project board feature where, it provides kind of like a visual overview in a Kanban style method, where you can have like maybe to-dos, just the way you have like, different kind of project boards where you can arrange your to-dos, arrange like tasks that are in progress, arrange tasks that are, that you want to move to done. So this kind of helps you facilitate collaboration better, like when a lot of people are trying to contribute to your project, especially in distributed teams. It helps you see like a real-time view of who is working on this, and how, how close the tasks are to completion, right? So that's these are ways that you could help optimize your workflow. Also, there are different tools. Like I said, open source goes beyond code. It's not just about writing code. There are also different features that GitHub offers to enable documentation, right? Like the wikis, you could documentation like README files, and README files are basically files, like I said, it's README is like a file that you can write up how people can run the project, what people do when they come there. You can also use GitHub Pages. GitHub Pages is also one way to put up documentation and wikis as well, to update your documentation and make it easily accessible to anyone. Another feature is, like I talked about, the project boards. That's also the same feature, and even discussions as well, to enable people talk better. Also, GitHub offers like the GitHub sponsors to enable people contribute money to your project, and ensure sustainability in your project. So just trying to wrap up here. we kind of prepared like some of the things that funders expect as you build your open source project. One of those things is publication in open access journals, publishing your journals so that people can be able to view your research, recognizing like the barriers that are associated with publishing, and like funders really help in these assets to cover those access fees, removing like those financial barrier. Also with open access to your research data, so ensuring that the data that you in your research project or your research process is made publicly available, is findable, is accessible, is also interoperable and usable across like different platforms as well, in different contexts. Also, ensuring that your project, your research project or your method, it has like a license so that
Yes, Raphael, over to you. I think this is the second group.
Hi, Joe. Yeah, I've done introduction to what we're doing already, so hopefully everyone's got the document and can kind of get to work on the session that we put together.
Great.
And I'm just going to be here for questions and to help out as needed.
Great.
Is there anyone who has looked at the document and isn't sure what to be doing or needs some help to get started? No? If not, that's great.
So much for engaging in the breakout session. It was really fun. And that also still has those steps outlined. So you can always, if you're not able to participate in the exercise, you can do it and you can also follow along. And, collaboration doesn't end here. I would encourage you to keep collaborating and contributing to the different projects. Let me go back to sharing my screen. 1 minute. Minutes. So thank you so much for engaging, like I said, in the breakout session. The collaboration doesn't end here. You can keep collaborating, and I've provided there are some community recommendations here, some resources that are really important that I think would be helpful to you as, researchers and as open scientists, and as you're creating your proposal and even creating open source projects. UNESCO, like I said, UNESCO is a big player in the open science space. So you can check out, they have working groups. Engaging in those working groups, engaging in the conversation is a great way to keep your, your ideas and your knowledge to be heard. So I recommend you check out this link. We'll share the slide, so you'll be able to access this link as well. The Turing Way is another community that I would recommend. Even the Center for Scientific Collaboration and Engagement, Community Engagement, also the Chaos Project. This is one of the foundation, like the open source projects I have been engaged in, and here we create metrics. If you remember during the session, I talked about moving from curation metrics, more of like reproducibility kind of metrics. So at the Chaos Projects, we create metrics to help open source software communities to measure health in their project. That we have a science and research working group, which you really we find useful to engage with. There's also Research Software Alliance in Africa. There's an African chapter which I've engaged with earlier on. There's also Journal of Open Source Software. This is like an open journal where you can publish work, and it has like a lot of published reports on open science and open source as well. And you can do more readings on through the the Jane Zuckerberg Initiative Open Science Program. They have a lot of resources there. You can check out the open source guide, it's like a guide that has a lot of components of open source and how to create readmes, how to collaborate in the community. You can also check out the Open Source Initiative. That's one of the bodies that kind of coordinates the open source movement, and they have a lot of resources on licensing, more conversations. You can check out more resources there. You can also check out UNESCO Open Science recommendation as well. From the diagram I shared earlier, there's a more condensed report, a more detailed version of a report that you can read. I would also add in GitHub Skills. GitHub Skills is a platform to learn more on like using GitHub as a platform. So I would add that in this slide, and I'll share it with Joel as well. So you can have access to checking out all these resources. I don't know if there are any extra questions. I think we have little time for questions, but this is my contact. You can always email me. I'm also active on Twitter and on LinkedIn at Ruti Kega, at Kega Ruth on LinkedIn, and Raphael, you can connect with Raphael as well on LinkedIn and also via email. And I don't know if there are any questions, any last questions. We have a few minutes left. If we can take them. Okay, I do not see any questions. Oh, okay, Chisom.
Hello, Ruth. Thank you so much. Are you from Nigeria? You look like one.
Yeah, yeah. Thank you.
Yes, I guess so. I'm from Nigeria too. Well done.
Nice to meet you, Chisom. Okay. Any more questions? Yeah, I didn't see any. Okay. Christine, is that? Let's see. I think I thought that was a question coming. Okay, do know. You can keep asking the questions. You can connect with either of us, facilitator, to ask questions via email or social media as well. And thank you so much. It's been a pleasure to introduce open science, open source, and I was excited to see a lot of people collaborating on other people's projects and creating projects as well. Thank you to Raphael for also co-facilitating with me, and thank you to the team at the African Population and Health Research Center. Thank you for inviting us to give this session as well. And I'll hand it over to Joel.
Thank you very much, Ruth and Raphael. This was quite a wonderful session, and we loved how the breakout rooms learned. I think that was great. We will actually share all the documents that you have shared with the participants so that everyone can keep practicing. And we'll also upload this session on our YouTube. So I'll put the links on the chat here, just in case you do not know our pages. And yeah, thank you. This was great. So I leave this back to, let me introduce Sylvia, who is part of the team. Maybe she can also point out something. Thank you.
Yeah, thanks. Thanks so much, Joel, and thanks to the team for our facilitators for such a great session. Really, I really liked that you introduced the topic at the beginning, and then you had the hands-on session and the breakout groups that were very interactive. I think we see the movement from just having code that is private to open source, whether it's open publishing, whether it's you need to share your data, and we know that all the trust issues continue to exist. But beyond that, there's more value in sharing a lot of what we do across, given that you're all writing proposals and they require you to collaborate to perhaps share some code. I think it's really a really good introduction to how you can start cooperating or collaborating on different projects or even writing some scripts. So thank you so much, Ruth and Raphael, for taking us through this session. Thanks to our participants. We are always pleased to see you here and for holding fort till the top of the hour. We are very grateful. So thank you so much and look forward to engaging with you further on this. Back to you, Joel. Yeah, nice weekend to everyone.
And thank you very much, Sylvia, for those comments. And if we don't have any other questions, I think we can close the session. And thank you very much. See you in our next session. Bye-bye.
Okay. Bye.
Thank
Bye.
you.
Bye.
Thank you.
Please, can you send in us all recordings?
Noun class. Yeah, Joel, I think you'll be sharing, we'll be sharing that.
Yeah. Oh, the ring. Okay, sorry. I forgot about the ring. Just a second.
Yeah.
But I'll also share in our WhatsApp platform. If you're not also on WhatsApp, you can ask me, I can add you.
Okay.